Hello student, our new point is critical speed. Now if you find out the formula for critical speed means critical velocity. We know that critical velocity means horizontal velocity of projection that must be given to a satellite to a certain height so that it can revolve in a circular orbit around the earth is called as critical velocity, or orbital velocity means critical speed denoted by Vc. So consider a satellite of mass m revolving around the earth at height above its surface. M be the mass of the earth, r be the radius of the earth, and small r is equal to r plus h if the satellite is moving in a circular orbital radius, and Vc is a critical velocity. So we know that centripetal force is exactly equal to gravitational force. Centripetal force means the force which necessary force for object to moving continuously in circular motion, and this force is acted toward the center of the circular object. So centripetal force is mvc square upon r is exactly equal to gravitational force gmm upon r square. Now rearranging this equation for Vc, so Vc square is equal to gmr upon mr square. Here rr and mm cancel out, and we get Vc square is equal to gm upon r, and so therefore taking square, then we get Vc is equal to square root of gm upon r, and since r is nothing but a capital R plus h, we put up this value instead of small r, then we get Vc is equal to square root of gm upon r plus h, and gm upon r plus h square is nothing but a gh, so gm is equal to gh r plus h bracket square. So we get Vc is equal to square root of gh upon r plus h, because gm is equal to gh r plus h. So r plus h square, one cancel out, and here r plus h come cancel out, and the remaining term is gh r plus h in square root. This is the expression for critical speed at the orbit of radius r plus h. When satellite is revolving close to the surface of the earth, then r is greater than h. So r plus h nearly equal to r, means radius of the earth. So we get here Vc is equal to square root of gm upon capital R. So therefore g is equal to gm upon r square, and gm is equal to gr square. So Vc is equal to square root of gr square upon r is equal to square root of gr, because here r square, here r and r cancel out, so we get last term Vc is equal to square root of gr, and the value of Vc is 7.92 km per second, because we know that the acceleration due to gravity small g, and r is the value of radius. So multiplying and taking square root, we get the value of Vc is 7.92 km per second. Now our next point is time period of satellite. Now we see escape velocity, then binding energy, and then critical velocity means critical speed. So now we find out a time period of satellite. So The time taken by a satellite to complete one revolution around the Earth is its time period. Means it's called a time period of satellite. So consider a satellite of mass small m, means the mass of satellite, to height h and provided horizontal velocity equal to the critical velocity. We see the satellite revolves in a circular orbit of radius small r is equal to r plus h. The distance traced by satellite in one revolution is equal to the circumference of the circular orbit within periodic time t. So therefore we get critical speed is equal to circumference of the orbit upon time period. So Vc is equal to 2 pi r is the circumference of circle and t is the time period. But Vc is equal to root of gm upon r. We know that the critical speed formula. So therefore comparing these two equations, so equation number 1 and equation number 2, so root of gm upon r is equal to 2 pi r upon t, or gm upon r is equal to 4 pi square r square upon t square, taking square root. So rearrange this equation for t square. So gm is denominator and r on numerator. So we get here r cube. So t square is equal to 4 pi square r cube upon gm. Since here pi square r and gm and 4 are this constant term and r is variable, so t square is directly proportional to the r cube. So square, that is the square of period of revolution of satellite is directly proportional to the cube of the radius of orbit. So therefore t is equal to 2 pi, here 2 pi in square root r cube upon gm. So therefore t is equal to 2 pi root of small r means r plus h cube upon gm. This is an expression for period of satellite revolving a circular orbit around the earth, and it depends on it only depends on the r and g and m. So the period of satellite does not depend on its mass, and it depends on its mass of the earth, radius of the earth, and the height of the satellite. So if the height of the projection is increased, period of satellite increases. The period of satellite can also be obtained in terms of acceleration due to gravity. So as gm is equal to gh in bracket of r plus h bracket square. So therefore t is equal to pi r plus h cube upon gh upon r plus h square, because putting a value of gm. So therefore t is equal to pi root of r plus cube and r plus square cancel out. So here remaining term only r plus h upon gh. So therefore putting r plus is nothing but a small r. So we get also t is equal to 2 pi square root of r upon gh. So when satellite revolves close to the surface of the earth, so r plus h is nearly equal to r and gh is equal to g. So time period means minimum period of revolution is 2 pi square root of r upon g. So this is the various formulas for periodic time of the satellite.